we are going to solve a problem based on beta function. The problem is given by express integral minus 1 to 1 1 plus x raised to n into 1 minus x raised to n dx in terms of gamma function. Okay, we need to use properties of beta function to prove this in terms of gamma function. We are going to get this by using substitution for x in terms of cos theta, and let's start with that. Okay, particularly we are going to use here property of beta function. The property is beta of p plus 1 by 2 comma q plus 1 by 2. This is equal to 2 times 0 to pi by 2 sine raised to p theta into cos raised to q theta d theta. Okay, where what is value of p? P is 2m minus 1 and q is nothing but 2n minus 1. We are going to use this property to express this integral in terms of gamma function. Okay, so let's start. Let's start with substituting x is equal to cos 2 theta. Why I am substituting x is equal to cos theta? Because we know that 1 plus cos 2 theta is nothing but 2 times cos square theta, and 1 minus cos 2 theta is nothing but 2 times sine square theta. So this is totally going to work to convert the given problem in terms of sine raised to p into cos raised to q. Correct? So what is dx now? Dx is 2 times this derivative is minus sine 2 theta d theta. I'll write down this as minus 2 times sine 2 theta is 2 times cos theta into sine theta d theta. Correct? And let's start with the next part, that is here what will be the changes in the integration, right? So let's decide what are the lower limit and upper limit. X and theta. X runs from minus 1 to 1. So when x is equal to minus 1 here, what must be the value of theta? Everyone knows that cos of pi is equal to minus 1. So I'll just write down here theta equal to pi by 2. So that this is going to be cos of 2 into pi by 2 equal to minus 1. Right? So that means what is my theta here? Pi by 2. And when I want this is equal to 1, and clearly cos 0 is 1, so I can take theta is equal to 0. Right? So limits are from pi by 2 to 0 now. Now let's go to next part. Okay, just let's see what are the changes in the integration. Now limits are from pi by 2 to 0. What is it? This is nothing but 1 plus x to the power n. What is x here? X is nothing but cos 2 theta. So this is 1 plus cos 2 theta raised to m into 1 minus cos 2 theta raised to n, and this is multiplied by dx. Dx is 1, 2. I am going to keep it outside because I need 2 here. So 1, 2 I am taking outside, and with the negative sign, and 1, 2 take it inside. So sine 2 theta into cos theta d theta. Right? Now let's simplify this. This is equal to, because of this negative sign, I'll change the limits, that is from 0 to pi by 2. 2 times, the first bracket is 1 plus cos 2 theta, which is 2 times cos square theta. This is raised to n. This is 2 times sine square theta raised to n into 2 times sine theta into cos theta d theta. and this is equal to 2 times, this is 2 raised to m into 2 raised to n into 2, so this is nothing but 2 raised to m plus n plus 1 into cos raised to 2m, and this is plus 1 theta into sin raised to n into sin theta is sin raised to 2n plus 1 theta d theta. Right, now when I am comparing this with the property which I have mentioned above, then in that case what we are having here, this is just a constant, take it outside, and what is it equal to? This is nothing but beta of p plus 1 by 2 comma q plus 1 by 2. What is p here? P is 2m plus 1, q is 2n plus 1 here, right? So in that case what we are having, this is nothing but beta of 2m plus 1 divided by 2 comma this is 2n plus 1 plus 1 divided by 2. So this is 2 raised to m plus n plus 1 into beta of 2 I can take common, so this is m plus 1 comma n plus 1, right? So by using the property that beta of mn is nothing but gamma of m into gamma of n divided by gamma of m plus n, this is equal to 2 raised to m plus n plus 1 into gamma of m plus 1 into gamma of n plus 1 divided by gamma of m plus n plus 1 plus 1 is 2. So we have expressed the given integral in terms of gamma function. So that's the proof.